Okay, just going to go over a quick explanation here. I had a couple of questions today on how do we know when we're drawing a terminal arm, say like this one out here in the third quadrant, how do we know whether we want to extend the triangle up to join with the x-axis or extend it across to join with the y-axis? Okay, so we'll take a quick look at why one is right and the other is not. So if my original triangle, or what I'm trying to do is relate one of these triangles to this original one up here. If I look at this, the blue triangle up in the corner, given that regular, positive angle, I don't know, I start with cosine here. Cosine of the angle is going to be my adjacent, x, over my hypotenuse, r, which I'm using r for just because it's the radius. Dealing with sine, I get the y value, which is the opposite, over the r, which is the hypotenuse. And of course, tan is the opposite y over the adjacent x. Now, when I look at the other two triangles that I've drawn down here, my two choices, my alpha and my beta, if I go to alpha first, cosine of alpha is going to have an adjacent over here. Can't maybe see that. Adjacent right here of negative x over a hypotenuse, which will be r. Sine of that same angle will be this opposite over here, a negative y over an r, and tan will be the opposite, negative y over a negative x, y over x. When I look at what would result if I chose the beta down here instead, cosine of beta is going to be the adjacent, which is this length here now, which is negative y over my hypotenuse. Sine of beta will be the opposite, which is now the negative x, and tan will be the opposite over the adjacent, which is x over y. So now if I look at these and compare them to the original one, you can see, hopefully, that up here, the green set of ratios are the same as the ones from the blue. The only difference is, in some cases, there's difference in signs. So cosine here has a negative value. Sine has a negative value. Yeah, okay, sorry. And tan is positive. That's what we expected down here in the third quadrant anyways. And so because the numbers will all be the same, I'll still have the same x's in the same spots, the same y's, and other than the signs, these ratios are all exactly the same as the ones we are trying to relate to. You can see then that when I look at the beta list down here, cosine is now being represented by negative y over r, which is clearly not the same as what we had in our original cosine, or what we would have in the cosine that we were trying to relate to. Same sort of thing with sine, and same sort of thing with tan. When I join my triangle here, my terminal arm from here, when I attach it to the y-axis, my sines and coses are reversed from what we want them to be. And so we want to make sure we always draw the triangle back to the x-axis. I sort of mentioned that once before. I'll just kind of put the diagram here as a final thing. And it's what I referred to as the butterfly rule, that basically in each quadrant there is a triangle with the same ratios, again changing only the signs at different points, and with the same angle on the inside. But it has to be drawn that way because that again guarantees that from that angle right there, I've got my adjacent, I've got my adjacent, I've got my adjacent here, and my adjacent here. So the x values will always be the adjacents. the y values will always be the opposites in all the cases. And that's not what happens if we join to the other axis instead. Okay, so again, butterfly, and the reason for it is it just ensures that we deal with the same adjacents and opposites all the way through.